Night hangs low over the Gulf of Finland. In the marsh air west of Leningrad, a line of dark rail cars sits motionless under camouflage nets. The wagons look ordinary at a distance: boxcars, a fuel tanker, a flatbed with a tarpaulin. Only the two central platforms give away the truth. Each carries a steel cradle the size of a small house, braced by outriggers and lashed to the rails. Inside the cradle, a barrel longer than a city bus points into the clouds. A voice calls out. A whistle answers. Lamps are doused. The great barrel tilts, breathes, settles. And then the night opens. The sound does not begin so much as arrive, like a door slamming on the horizon, followed by a second door and a third, and the air itself buckling between them. A white cone of flash, a tongue of flame. On the far side of the Gulf, a German artillery park wakes up to an earthquake in the sky. The shell travels for close to a minute. When it lands, the crater will be large enough to swallow a cottage. This is the Soviet TM-3-12, a 305mm naval gun taken off ships and put on the rails, a weapon designed for the sea, reborn to answer a siege on land. Railway guns did not begin in the Second World War. They were an invention of the previous one, a time when moving super-heavy guns across mud and ruined roads often proved impossible. A railway line, if intact, offered a solution. Steel wheels on steel rails could move weights no horse team or truck could manage. The French, the Germans, the British, and later the Americans experimented with guns on rail carriages. By 1918, the idea was firmly established. If you needed extreme range and shell weight, rails were the way to carry it. The Soviets inherited this logic and the hardware to match. At the turn of the 20th century, Russian naval yards had equipped their new dreadnoughts, the Gongut-class battleships, with 12-inch, 305mm guns manufactured by the Obukhov Works. Those 305 .52 caliber guns, 52 representing the barrel length in calibers, were accurate, hard-hitting, and produced in significant numbers. After the First World War and the Russian Civil War, several spare barrels remained in naval depots. Others sat in coastal fortresses guarding approaches to key ports, such as Kronstadt. By the late 1930s, Soviet planners faced a geography and a threat picture that favored long-range fire. The Baltic approaches could be interdicted from shore. The cities on the Gulf of Finland might need to fire across water and marsh at enemies who would try to stand just out of reach. And the Red Army's doctrine expected fixed defenses to be tied to mobile support, artillery that could reposition quickly yet bring battleship-class power. A series of railway artillery mountings appeared from this thinking. Designations varied by gun and carriage. TM-1-180 for 180mm naval pieces, TM-2-12 and TM-3-12 for the 305mm class. The letters TM are commonly understood to indicate a factory designation for transporter, railway, 12-inch, though sources differ on the exact expansion of the initials. What matters most is the concept. Take a proven 12-inch naval barrel and create a railway cradle that can absorb its recoil and aim it with precision. By 1938-1939, a small number, Most sources say 3 of the TM-3-12 carriages were completed and assigned to the Baltic Fleet's coastal artillery arm. Number of carriages estimated at 3. Documentation is consistent but not identical across archival references. Each carriage was a feat of heavy engineering. The gun sat in a steel cradle on a turntable fixed to the rail platform. Enormous hydraulic or spring-compressing recoil systems, again depending on the sub-variant, caught the barrel's backward surge and returned it to battery. Because a battleship turret could rotate freely, but a railway carriage could not, the designers solved traverse in 2 ways. A small degree of horizontal movement was possible on the mounting itself, while large azimuth changes were achieved by rolling the entire carriage along a pre-laid curved track called a firing arc. In practice, firing positions were prepared with sections of rail that formed a shallow segment of a circle, allowing the crew to move the carriage a few meters forward or back to slew the barrel. The real test came with war. In June 1941, Germany and its allies invaded the Soviet Union. By September, the Wehrmacht had encircled Leningrad from the landward side, and the Finnish army pressed from the north. The city's lifeline ran across Lake Ladoga. Its shield included everything that could throw steel across distance: army howitzers, fortress guns, naval batteries, and the railway guns of the Baltic Fleet. The TM-3-12s were among them. They served as part of an integrated coastal artillery system that predated the war, commanded through the Kronstadt fortress, and later directly tied to the defense of the Oranienbaum Bridgehead, the Soviet-held pocket west of Leningrad that never fell. From those rails, and from nearby prepared positions, the 305mm railway guns could fire on German rail junctions, artillery concentrations, supply dumps, and strong points that lay beyond the reach of standard field guns. They could also reach out to sea if needed, but during the siege, their primary purpose was on land. The shells they fired were substantial. A typical high-explosive projectile for the 305-52 weighed in the neighborhood of 470 kilograms, over 1,000 pounds, though exact weights varied with model and purpose. Shell mass and range, estimated within common published ranges. Exact figures differ slightly across manuals and post-war summaries. With full charges and high elevation, ranges of several tens of kilometers were achievable, sufficient to strike targets far behind the front line. At these distances, accuracy depended on careful preparation, survey work to pin down the gun's position and elevation, firing tables adjusted for temperature and wind, and spotters to correct fall of shot. Spotting could be done in several ways. Observation posts on church towers or factory chimneys watched through high-power optics. Aircraft, when the weather and enemy permitted, could relay corrections by radio. In winter fog or snow, even sound ranging mattered. Microphones placed along the front could detect the boom of a heavy gun and help triangulate German batteries for counterfire. Railway guns worked best when part of this network, a chess move coordinated with many eyes. A battery was more than a barrel and a platform. It was a traveling village. Each TM-3-12 was accompanied by an ammunition train, boxcars lined with wooden racks, shells in cradles, brass propellant cases stacked like barrels in a wine cave. There were crew cars for gunners, loaders, telephonists, cooks, and mechanics. There were power cars with generators and compressors. A small workshop rode with lathes and spares. And there were security details, riflemen to guard the perimeter, sentries at signals, camouflage teams with nets and paint. On paper, the crew to operate a 305mm railway gun numbered dozens. In practice, the whole battery, guns plus support, ran to several hundred people. Division of labor was precise. Powder charges came from one car, shells from another. A traveling crane or gantry moved the projectile to the loading tray. The breech, massive, square-shouldered, steel, opened and closed like a vault door. Orders came by field telephone. A chalk-covered board recorded elevation and azimuth. When the word came, "Fire," every man had a job, and they did it with a ritual's calm. The Germans, for their part, tried to find and silence the guns. Counter-battery fire was immediate and often heavy. Every firing would be answered by clusters of 210mm, 150mm, and 105mm shells raining down on suspected positions. Any artillery muzzle flash at night risked a hail of retaliation. The Soviets adapted. The batteries learned to fire a short series of rounds and move at once. The advantage of rails, if you could keep the lines intact. Camouflage improved. Nets, dummy guns, smoke generators. Positions multiplied. A battery might have several prepared arcs and decoys, cycling among them to confuse sound ranging. Railway troops repaired damaged lines at speed, relaying track under shell fire. In this duel of engineers and gunners, the TM-3-13s were both targets and hunters. What were they like to stand beside? Survivors remembered heat and concussion. With a 12-inch gun, blast is a world unto itself. The bow wave of pressure slaps the skin. Dust lifts from every surface. The ground trembles. Hearing protection, wads of cotton, later proper plugs, was non-negotiable. After a salvo, crewmen had to wipe sweat and soot from their faces before reading instruments again. And yet for many, there was pride. To run a gun built for a battleship. To answer the siege with a voice that could be heard across the Gulf. It felt like turning the city's whole industrial heart into a fist. Numbers tell part of the story. Wartime reports credit Leningrad's railway and coastal heavy guns with thousands of rounds fired across the siege years. Per gun totals for TM-3-12 are less consistently documented in public sources. Surviving data for comparable batteries suggests a rate of fire measured in a handful of rounds per hour, constrained by loading time, barrel heating, and the need to maneuver between salvos. Ammunition was precious. Where on the barrels, the erosion of rifling under extreme pressure had to be tracked. After so many equivalent full charges, a gun needed relining or retirement. Naval depots provided spare liners, and crews learned to husband each shot. Beyond the physical damage they inflicted, the railway guns had a second purpose: shock. German reports mention heavy Soviet shells that cratered roads, collapsed dugouts, and, most importantly, forced units to disperse and dig deeper. A headquarters that would have parked its radio truck beside a brick wall now had to hide in a cellar. A rail junction that could have turned trains under daylight had to do so at night. Every change like this slows an army. On the Soviet side, that delay was life. It meant fewer shells landing in Leningrad's markets, less accurate fire on the Ladoga ice road, a breathing space for factories working behind blackout curtains. The Leningrad front was not the only theater to see heavy railway guns, and the TM-3-12 was not alone in its class. Smaller 180mm guns on TM-1-180 carriages served along the Baltic coast and on other fronts. Coastal fortresses around Kronstadt and at Krasnaya Gorka mounted turreted 305mm guns on fixed emplacements that complemented the mobility of the railway batteries. Elsewhere in the Soviet Union, other fronts experimented with rail artillery for counter-battery and interdiction work, where rails remained usable. But the TM-312's name is most closely tied to the Gulf of Finland and the siege. For all their power, railway guns carried limitations that only grew as the war progressed. They required intact rail lines and prepared firing arcs. They were large targets for air attack, especially in clear weather. While camouflage and coordination with fighters helped, they could not simply vanish into woods like a truck-towed howitzer. Their rate of fire was slow, and resupply was a heavy burden. As the Red Army adopted more mobile artillery tactics and massed conventional guns with better logistics, the relative advantage of a few super-heavy shots diminished in some contexts. And yet, when the siege tightened and conventional means were not enough, there was no substitute for a long-range sledgehammer. When the front needed to hit a depot across marshland beyond the reach of 152mm howitzers, a 305mm howitzer across the rails could do it. When a German battery on a distant ridge refused to be silenced, a railway gun's plunging shell could shatter its concrete. When morale on the line sagged under days of shelling, the boom of a friendly giant was a reminder that the city still had teeth. By early 1944, Leningrad's siege would be broken by ground offensives. The January push that drove the Germans away from the immediate environs, followed by the summer campaign that took the front ever westward. As the lines moved, the role of static coastal and railway guns shifted again, back to guarding seaways, supporting amphibious operations, and denying the enemy any foothold on the shore. The TM-312s survived to see that turn. After the war, at least some of the remaining carriages continued in service with the Coastal Artillery Branch for years, a reminder of a time when a city fought not only with men and bread, but with the physics of steel and distance. Post-war disposition. Details vary. Sources indicate continued service and eventual decommissioning as missile-age coastal defenses replaced large-caliber guns. To understand the TM-312's place in the broader history of the Eastern Front, it helps to compare it with Germany's own rail giants. The German Army deployed Krupp's 28cm K5E railway guns, the famous Anzio Annie and its siblings, to considerable effect on the Western Front, and experimented with even larger monsters like the 80cm Dora, though these were rare and logistically extreme. The Germans also used heavy siege mortars and long-barreled 17cm guns with great skill. Both sides recognized a truth. Super-heavy artillery was a specialist tool. It was not a weapon to win battles alone, but to break a specific lock, destroy a concrete node, deny a rail yard, force a reorganization. In the unique geography of the Leningrad siege, with water, marsh, and a ring of enemy guns, the TM-312s found a battlefield that suited them. There are still debates around the details. Exact production numbers and subvariant features of TM-212 versus TM-3-12 are a matter of specialist literature, with different authors citing different factory records. One reason this script distinguishes carefully between what is documented and what is estimated. Precise engagement lists, this target hit on this day by this gun, exist for some actions and remain incomplete for others. A normal outcome when heavy batteries fired into areas where frontline units could not always verify effects. The broad lines, though, are consistent across official histories and unit accounts. 12-inch naval guns on railway carriages fired from the Leningrad area throughout the siege, supported by the Baltic Fleet's Coastal Artillery Command, and delivered long-range fire that contributed both physically and psychologically to the city's defense. There is also the human layer, less visible in tables and diagrams. Consider the crewman whose job was to swab the bore between rounds, leaning into a steel tunnel that stank of hot oil and burned powder. Consider the telephonist listening to corrections in a voice gone hoarse from shouting over concussions. Consider the railway engineer kneeling in the snow to spike down a fresh rail segment under air raid sirens. Or the spotter on a smokestack with a notebook, counting seconds to impact by the cadence of his own breath. Each of them was part of the firing of a single 305mm round. Each of them was a link in a chain that ran from a factory in 1912 to a siege in 1941 to a city that still stands. Technically, the weapon rewards close attention. A 305/52 gun develops prodigious muzzle energy. Numbers expressed in megajoules translate into recoil forces that would rip apart a normal carriage. The TM-3-12's mounting, therefore, used massive bed plates and outriggers, fold-out steel beams that pressed to the ties or to reinforced foundations to spread load. Before firing, the crew lowered these supports and locked the carriage. After firing, they unlocked, retracted the outriggers, and, if counter-battery risk demanded, moved. Elevation controls were geared in fine increments. Traverse on the mount allowed only a few degrees either side, making the quality of the prepared arc vital. The gun's breech mechanism, of the interrupted screw type used on naval pieces of its generation, required perfect choreography. Opening, scavenging gases, loading the shell with a power rammer, seating the propellant, closing, checking obturation, and aligning safety interlocks before the firing lanyard could be pulled or the electric trigger pressed. The ammunition came in types familiar to naval gunnery: armor-piercing shells designed to penetrate thick plate, and high-explosive shells with thinner walls and larger bursting charges intended to demolish soft targets and fortifications. In land warfare around Leningrad, high-explosive loads predominated, crushing bunkers, rail cuts, and troop concentrations. Fuse settings, instantaneous for surface bursts, delayed for penetration, were chosen based on target, soil, and desired effect. Crews kept careful records, building local firing tables that corrected official values with real-world experience. How much a marsh soaked up blast, how a winter temperature swing shifted propellant performance. If you trace the arc of a single salvo, you find a small play. The first act is calculation and preparation. The second is the shot and its echo. The third is silence and consequence. On the receiving end, German batteries had their own math. They used flash spotting and sound ranging to locate the Soviet guns, then poured counterfire into the suspected arc. Even when they missed, their shells tore up rails, shredded camouflage nets, and killed sentries caught in the open. The railway troops' answer was speed. Repair parties that could replace ties and rails in minutes. Spare arcs laid in advance. Locomotive crews who knew how to move 100 meters under bombardment without derailing. The duel never stopped. What finally did the TM-3-12s achieve? They did not lift the siege by themselves. They did not feed the city, open the Ladoga Road, or storm the German trenches. Those were tasks for soldiers, sailors, airmen, and civilians across every service and factory. But they did change the physics of the battlefield. They extended the Soviet reach by dozens of kilometers. They forced the enemy to dig deeper, to hide, to slow down. They hit targets that would otherwise have been untouchable. And they gave a city under constant fire a sound that said, "We can strike back." Today, remnants of Soviet railway artillery survive in museums and memorial sites. Visitors climb stairs to stare down bores that look like tunnels, run their hands along rivets and bolts, and try to imagine the tonnage moving as if it weighed nothing at all. It is easy, standing beside a silent barrel, to think only of size. But the true legacy of the TM-3-12 is more than material. It is a problem solved under pressure. How to convert what you have, naval guns, spare barrels, rails, into what you need, which is range, power, and the ability to move. It is an illustration of logistics as a weapon. And it is a story about adaptation, about a port city that learned to fight like a battleship, even while frozen to the land. The night on the Gulf ends the way it began. The crew secures the breach. The outriggers lift. A locomotive coughs to life and eases the train back into the trees. Snow begins to fall, gentle, indifferent. Across the water, somewhere in the dark, men in other uniforms brush plaster dust from their coats and listen for the next round. Between them stretches the silence of distance, and the rails that, for a time, could bridge it with fire.